Imagine this. You're going about your day, touching doorknobs, scrolling your phone, chatting with a friend. Nothing unusual, but floating around in tiny droplets that you can't see, something else is moving too. Something so small that tens of thousands of them could fit inside a single pinhead. Something that changed the entire world. Ever wondered where you really come from? Not the stories, but the science. On this channel, we decode real DNA, uncover lost ancestries, and bring ancient genomes to life through cinematic storytelling. If that excites you, subscribe for weekly insights, like the video to support science-based history, and drop a comment. Your questions help guide what we explore next. This is SARS-CoV-2, the coronavirus responsible for COVID-19. We've heard about it on the news, seen charts and headlines, and lived through lockdowns. But what actually happens inside your body when you're infected? How does this microscopic organism infiltrate your lungs, cause inflammation, and in severe cases, even shut down your respiratory system? And most importantly, how do vaccines teach your immune system to fight it off before it's too late? To answer all of this, we need to shrink down, far smaller than a grain of dust, and explore the coronavirus on a molecular level. Let's dive into the world of viral particles, cellular defenses, and the incredible biological battle that begins the moment this virus enters your body. Meet the virus. This is SARS-CoV-2, a member of the coronavirus family, named for the crown-like spikes that ring its surface. Those spikes aren't decoration, they're tools. Tools designed to unlock, invade, and hijack the cells inside your body. SARS-CoV-2 is essentially a microscopic capsule carrying one mission: get inside a living cell and make more of itself. At its core lies the virus's genetic material, RNA. This RNA contains the blueprint for building future copies of the virus. Surrounding it is a protective protein shell, acting like armor as the virus travels from one person to another. And wrapped around all of that is the lipid envelope, a soft outer layer that helps the virus fuse with your cells. But the real star of the show is the spike protein, the part that reaches out like a key, searching for the right lock. Compared to viruses like influenza, SARS-CoV-2 is particularly efficient at binding to receptors on human cells, especially a receptor called ACE2, which is found throughout your respiratory system. Once a viral particle finds a suitable cell, its spike protein latches on tightly, making it incredibly effective at securing entry. And here's the catch: the virus itself can't reproduce without you. It doesn't have the machinery to build anything on its own. It needs your cells, your energy, your resources to make thousands of new viral particles. That dependency is what makes viruses so dangerous. Once inside, they turn your body against you. But how does this invasion actually begin? To find that out, let's follow the virus from the outside world into the deepest pockets of your lungs. Entry into the body. The moment an infected person talks, coughs, or even breathes near you, tiny droplets containing SARS-CoV-2 can drift through the air. If you inhale them, or if they land on your eyes, nose, or mouth, the virus immediately starts searching for a place to settle. It doesn't take long. The cells lining your nose, throat, and upper respiratory tract are packed with the ACE2 receptors the virus needs. Once a viral particle reaches one of these cells, the spike protein acts like a key, sliding into a lock. It binds to the ACE2 receptor, pulls itself close, and merges its outer envelope with your cell membrane. This fusion opens the door, allowing the virus's genetic material to slip inside. A typical flu virus must travel all the way into the nucleus before it can begin replication. But SARS-CoV-2 is much more efficient. Its RNA doesn't need the nucleus at all. Instead, it heads straight to the ribosomes, tiny molecular factories floating in your cell's cytoplasm. These ribosomes read the virus's RNA and begin producing viral proteins, including more spike proteins and copies of the virus's internal components. Around your cell, packaging structures called the Golgi apparatus and endoplasmic reticulum gather these newly made parts. They assemble them into fresh viral particles, each fully equipped with its own genetic material and spike-covered envelope. Soon your cell's surface begins to bulge as the viruses push outward. One by one, they bud off, wrapped in pieces of your cell membrane. Within hours, a single infected cell can release tens of thousands of new viruses. And while that cell struggles to survive, the swarm of newly released viruses spreads outward, searching for more cells to hijack.
Spreading through the respiratory system. As SARS-CoV-2 multiplies, it spreads deeper into your respiratory system. What began in the cells of your nose and throat gradually advances down your windpipe and into the branching airways of your lungs. These airways, your bronchi and bronchioles, are lined with mucus and tiny hair-like structures called cilia. Their job is to trap invading germs and sweep them upward so you can cough them out. But the coronavirus doesn't go quietly. Infected cells become overwhelmed and start releasing distress signals. These signals trigger inflammation, swelling, and irritation along the lining of your airways. The cilia slow down, the mucus thickens, and the virus continues forcing its way downward. As more cells fall under viral control, your body senses the growing threat. Immune cells rush to the infection sites, attempting to contain the damage. But the virus replicates too quickly, slipping past the defenses and spreading from one airway branch to the next. This is when many people begin to feel the early symptoms: a scratchy throat, a dry cough, a low fever, or a strange heaviness when breathing. If the infection remains in the upper respiratory tract, your immune system may keep it under control. But if the viral load grows too large, or if your immune response is slow or weakened, the virus reaches the most vulnerable and vital part of your lungs, the alveoli. These are the tiny, balloon-like air sacs where life-sustaining gas exchange takes place. Every breath you take fills these sacs with oxygen, which passes into your bloodstream while carbon dioxide flows out. They are thin, delicate, and essential for survival. And once SARS-CoV-2 breaches this area, the real danger begins. How pneumonia develops. When the virus reaches your alveoli, tiny air sacs at the ends of your bronchioles, the battle inside your lungs intensifies. These tiny sacs are designed to remain open, flexible, and filled with air. But once infected by SARS-CoV-2, they become ground zero for inflammation. Inside each alveolus are immune cells that usually defend your lungs from everyday threats: dust, bacteria, and harmless particles you inhale regularly. Under normal conditions, they eliminate invaders quickly and efficiently. But the coronavirus reproduces at such a rapid pace that even these specialized cells begin to struggle. As they fight back, they release chemical messengers that call for reinforcements. These reinforcements include white blood cells, fluid, and proteins meant to contain the infection. However, this strong immune response has a side effect. The alveoli begin to fill with fluid and cellular debris. Instead of acting like airy balloons, they become heavy, waterlogged, and unable to expand. This greatly reduces the amount of oxygen that can enter your bloodstream and the amount of carbon dioxide your body can release. As more and more alveoli become inflamed, large portions of your lung tissue stop functioning properly. This leads to pneumonia, an infection of the lungs that interferes with breathing. Depending on how the inflammation spreads, you might develop lobar pneumonia, which affects a single lobe of a lung, or bronchopneumonia, which spreads patchily through multiple regions. This is when symptoms become much more severe. Breathing becomes difficult, even painful. Your body may struggle to get enough oxygen, causing shortness of breath, rapid breathing, or a feeling of tightness in your chest. You might experience fever, chills, fatigue, headaches, and a persistent cough as your body attempts to clear fluid from your airways. If the immune system manages to balance its response, the swelling might gradually subside, allowing the alveoli to reopen and your breathing to return to normal. But in some people, especially the elderly or those with underlying health conditions, the immune reaction can spiral out of control, and that's when the infection can become life-threatening. In the most severe cases, the inflammation inside the lungs becomes so overwhelming that oxygen levels drop dangerously low. When the body can no longer keep up, doctors may need to use a ventilator, an external machine that helps push air into the lungs so the patient can continue breathing. This support can be life-saving, giving the immune system more time to fight the infection and repair damaged tissue. But not everyone will experience severe symptoms. Age, overall health, and the strength of your immune system all play a role in how your body responds. Many people recover with rest, hydration, and supportive care. Others may require medical treatment, especially if their lungs struggle to deliver enough oxygen. This is why vaccines play such an important role. When you receive a COVID-19 vaccine, your body is introduced to a harmless version or piece of the virus, often the spike protein itself. This exposure doesn't cause the disease, but it trains your immune system to recognize the virus instantly if you encounter it in the future. Your immune cells begin producing antibodies that specifically target the spike protein, preventing the virus from attaching to your cells. With this early warning system in place, your body can shut down the infection long before it reaches the lungs. While scientists continue to improve vaccines and treatments, the most reliable protections remain simple. Wash your hands regularly, avoid close contact when you're sick, and stay home when possible during outbreaks. These small actions help protect not only you, but also the most vulnerable people around you. COVID-19 has shown us how astonishingly complex and resilient our bodies are, and how a microscopic virus can disrupt that balance. But it also highlights the power of science, medicine, and collective effort. By understanding what happens inside the body, we're better prepared to fight back, protect each other, and move towards a healthier future.